Welcome to the podcast, and thanks for being here. And you can just begin by telling us who you are, what your journey is, and how you got to be working on hydrokinetic energy.
So my name is Roisin McCormack. I'm the CEO and co-founder at GKinetic Energy. We're an Irish-based company, so we've been around since 2014. And as we have a little bit more time today, I can go into the origin story because it's really fun. So myself and my father are both sailors. We spend a lot of time on the water. My dad, Vincent in particular, he does a lot of sailing. He's done transatlantic crossings. So the actual concept or the spark for the company came about one day when he was trying to tie his boat up onto a mooring. And he was really struggling, he's able to do it, but just the tide was really strong and he was struggling to tie the boat on. And he just looked upstream of that, and just upstream, the water was completely calm, like nothing was happening. But where the mooring buoy was this force and this power. And he just observed that and was like, as the water was flowing around this obstacle, there was very clear points of accelerated flow either side of it. And that was basically where it all came from. So he was in construction and property, and there was a huge crash. And he always had this fascination of how do you generate energy from water in a very simple, safe way. He founded the company a couple of years later. We purposely kept it small for a long time. So we had seen a lot of people in the space, growing really big companies and promising huge machines, like megawatt scale machines. And, unfortunately there were failures, and we were like, that does not look fun.
I'm going to stop you for 1 second.
Yeah.
Sorry, it's a tricky location for us today, and we didn't get any.
Yeah.
So you had this idea, or your dad had this idea, saw the big projects failing, and then you thought, not for us, something else.
Yeah. So we had this simple concept of, how do you generate power from free-flowing water, simply and safely. And as I said, some of the other competitors were building really big units and, they were failing. So we just said, look, let's keep this really small, keep it fun. So we just, in a very, I suppose, de-risked staged way, just started putting units in the water. So that's one of the things we're very proud of, is we've put a lot of kit in the water.
Where'd you build them in the early days?
In our workshop. So we have a pretty sizable workshop, just where our offices are. So we can build a couple of units there at a time. So now some of the other bigger ones, earlier on, we would have subcontracted them out to proper marine grade, engineering outfits. So
tell me about that middle journey where it was still very much an experiment. How did that go?
Very
How long
much.
did it take as well?
Yeah, it took a while. We're on the go since 2014, and sometimes we do get a bit of kickback saying you've been around, quite a long time. What's taking you so long? But for us, it's always been really important to actually know that the thing works. It sounds so simple, but a lot of people, they just, they start to scale before they've actually figured that out. And, the marine environment is not a friendly testing ground. It's really rough, it's really harsh. So if you put $1 million piece of kit into the marine environment and it's not working right, that's an expensive experiment. So we kept it really small scale, and we did pivot a lot of the times. If you look at the really early stage designs of our unit, it looks like a fish. So it actually had a tail and everything. And just purely through lots and lots of testing and getting it in the water, we just kept reiterating the design, kept improving the design. So, the core concept has always remained the same. So that's what I was talking about with the mooring buoy. So basically what makes us really unique is this bluff body concept. So you actually put an intentional obstacle in the water. It's forced out and around it, and it goes into these vertical axis turbines. And nobody else is doing that. Everybody else funnels the water in through their devices.
I find it really interesting that you both have the sailing background. I feel like there's a little bit of intuition which comes from being in water, which probably certainly helped in the early days.
Definitely,
the fact that your father was even observing how water is moving differently in a river while trying to moor a boat is certainly something.
I was forced into it. My dad did it by choice. I was forced. Seriously, from a young age, I remember being literally brought out onto boats against my will and having no interest at all in it. And then when I was about 15, we got a different type of boat. It's a really beautiful Irish traditional wooden boat. And we got one of them and we started racing. So my dad will go off and cruise for a couple of months at a time, but I love racing. Cool. So it was when we started racing that my, I suppose, love for it was born.
Right.
So.
We haven't even described yet what exactly it is that you built. So maybe let's just go there before we continue on with the rest. So give us a good description of what it is you guys are actually making. And maybe you can start with the problem that you're trying to solve first.
Yeah. I suppose the kind of big macro problem is everyone knows that there's huge energy potential in water. Nobody denies that. But 90 to 95% of our waterways flow at speeds less than 2.5 meters per second. These are average flow speeds. And, traditional hydro or competing devices, they all struggle with how do you generate enough power at these lower average flow speeds, without damming the waterway or creating these huge height drops, which then is obviously causing massive disruption to the ecosystems. So it's this belief that you can and should be able to do both. You should be able to extract the energy while also working in harmony with the ecosystem. And that's the problem that we're solving basically is, yes, it is possible to do that. And then by solving that problem, we're making this incredible energy resource accessible to everyone really who's alongside these fantastic resources.
And can you just give a bit more of a description of how you're splitting the water using vertical axis turbines? This is sort of your unique idea, right?
Yes, yeah. And I love to always say to people, the next time you're crossing a bridge, look down at the pillar of the bridge, because that's our core, kind of design feature working in real time. So it's just an obstacle in the water. As flowing water approaches an obstacle, it creates a pressure field in front of it. The water is condensed, it accelerates out and around it. And we just capture that accelerated flow either side of that obstacle essentially. So we have 2 vertical axis turbines. Sounds really simple, but we've put a huge amount of work into. So the bluff body is very basic. That's literally just, semicircle obstacle. But the actual, the turbines themselves, so our blades and our pitching system, we've put a massive amount of work into as well. So they're basically always at optimum lift and they're always extracting as much power as possible out of the flow. So we've 2 patent families, one on the overall concept and design of using that obstacle. And then the second patent family is on the blade pitching system.
Right. Yeah. So it seems kind of counterintuitive that all you had to do was drop something big and put it in the way first.
I know it does. Yeah.
And from there, it was about refining. Okay, how do we get the blades to do their thing as efficiently as possible?
Yes. Yeah.
Let's talk about those blades. So they move only at the speed of the actual water flow. Is that right?
Yeah.
And so you're having a lot of gearing down through that whole system, I assume, to get usable energy out of slow flowing water with still a slow moving blade as well.
Yes, yeah. So a lot of that as well is the power control system that we use is very much designed in tandem with the blade pitching system that we use. So yeah, it's a really nice feature that works very well. But as I say, it sounds really simple, but we've put an awful lot of work into getting that to work properly. But our blades move incredibly slowly. Like you can literally, we've been inside, like alongside them in the water, and you wouldn't stop it with your hand, definitely not. But it's super safe. And then for fish or anything like that, it presents almost as a static object in the water.
Is the slow flowing aspect is also really interesting to me. I mean, I followed lots of weird vertical axis wind turbine projects over the years, which have sort of popped up and then disappeared, which are doing the same thing, trying to capture slow moving erratic wind energy. And it seems to be a really tough nut to crack. I guess in water, you've got a lot more density to work with, at least.
Absolutely, yeah. So the power density is way higher in water, and that's a huge thing as well with just the resource itself and why it's so important that we actually tap into this resource and use it, because it's an incredible source of power compared to solar and wind. Now, I'm a huge advocate, especially for solar. So we're very much kind of following the pathway that solar has paved, that kind of modular. And it's the same thing with our turbines. If you've got like a small river, you put in one. If you have a wider river, you put 6 or 7 of them across the width of the river, or you install them in tidal applications, in which case, it's just what size do you want it, basically. It's the same as mooring a device, So
it's not about making the device bigger, but just if you need more power, add more devices.
Yes, yeah, right? Absolutely, yeah.
I'm very curious about suitable sites. I assume part of what you're doing is saying, hey, there's probably a lot of slow moving water. Have you guys done any analysis to look at how much energy or how much space or how many suitable places actually are there? Is it huge and it's like this massive untapped resource, or is it actually not that big and it's just a niche little side hustle?
It's so big. And I hate when people throw out these like huge numbers that they kind of seem almost too big to even count. But like Ireland is not our best market, but it's still our beachhead market, because even as like a not ideal market, there's more than enough sites and demand in Ireland for it, So we've 73,000 kilometres of rivers in Ireland. And then like just to compare that, there's about 90,000 in the UK. Like one state in America will have the equivalent of of that, you know, like the whole of America has 4.8 million kilometers of rivers, which is, you know, mind-boggling. So we are now very focused on rivers. So we started out as a tidal company. Most of our deployments have been in tidal environments. But to be totally, you know, honest, we've struggled with the actual business model and like how do you repeat tidal units? Because again, you know, you have to know who's taking the power, and then when you're dealing in marine tidal environments, you have to get foreshore licenses, and you know, you have to run cables. It's a much more complex, I suppose, project. But the river one, I suppose, is just quicker way to get these out into the market. It's kind of similar with solar. Like solar started like, you know, grassroots level, like people just putting up small solar units. Yep. And now you can see, you know, all the utilities, the, you know, the huge solar farms and plants that are happening. But it took 30 years to get there, you know. So what we want to do is just get the kid out into the real world, having like a very clear, tangible impact so people can start to understand it, and us as well, that we can gather, you know, all the data that we need to gather to say this is absolutely not having negative impacts, and then you scale it up. Yeah. You know?
I mean, are there any serious concerns about negative impact? It sort of seems like because you're in also a very low energy environment with slow moving parts, it seems like the potential negative impacts are pretty low just by default.
Yes, yeah.
Are there any major obstacles you still have to like de-risk in terms of environmental concerns?
Nothing major, I would say. We've had planning granted in a Natura 2000 site, so it's basically like one of the highest levels of, you know, a protected site, which was massive. So that was like all the authorities saying, yes, we think that this is really safe. It's not going to cause any negative impacts. But for any of our, you know, our initial deployments going into real sites, we're going to be doing tons of data, and we want to do that. We're driving that just as much as like the councils or the authorities are asking for it. So we're going to be doing, you know, noise monitoring, we're going to have cameras, and we're trying to, as much as possible with our initial pilots, to pull in as many partners and, you know, universities, do as many studies as possible, because we want to say, like, it's really important for me, because I'm very, very passionate about, you know, nature and animals and the environment. Like, I would cry if I saw a bee in trouble and I have to stop and help it, you know. So it's really important for me to know, like, we're putting these in and they are not having negative impacts. Yeah. And the other brilliant thing about the units and the way we deploy them is, if there is something negative happening, we just take them out. They're so simple to take in and out. We had a unit up in Northern Ireland, a 12 kilowatt unit, so it was pretty sizable. It was about the size of like a big car. We took that in and out at least 15 times over a couple of months of testing. It was like, you know, a 10-minute job to take it in and out of the water. So that's the other great thing about them is, you know, you can just move them.
Just put on a trailer.
Yeah, move it somewhere else. Yeah. Travelling turbine.
I think this is a good time to bring up the what we were discussing earlier as well, is the sort of paradox of scale. Of the bigger stuff gets, the more efficient can become. You know, cities are these big, crazy, dense places that need a big, crazy, dense power source. And then the smaller and more distributed they become, in a way, you could say maybe the safer they become. Yeah. How do you guys think about this? Do you think it's both and? Do you think it's like, no, we need to decentralize everything? Only little river generating boats all over the world?
Yeah, I suppose it's part of, you know, we have a very clear vision for the company. We still are very much looking to scale the units up and have bigger units out generating bigger power. So it's something that's just happened very organically, where we just kept getting inquiries from farms and manufacturing plants and homes, like alongside the coast or alongside rivers. Because they're the ones feeling the pain the most at the moment. So like certainly in Ireland, almost 30% of Ireland's power is now going towards data centres. And the data centres...
30%?
It's absolutely crazy. And people are really starting to... just feel very resentful, you know, like that the system is not working for them, because it's the homes and the businesses that are paying the price hikes, whereas the data centres...
Have the prices gone up at the meter level for individual homes and small businesses?
Yeah, massively, yeah. So like the average price in Ireland now is about 34 cents per kilowatt.
And what was it before?
Like if you go back a year ago, it would have been 27, 28, maybe less. It depends, you know, like obviously if people are shopping around, but like it's just consistently going up. And we're already being told it's not even the cost now, it's about the guarantee of supply. So like the major grid operator in Ireland now has already come out and openly said, we're going to have major issues by the end of next year, like in terms of actually being able to supply you. So I think with everything, there is no one solution that's going to solve everything. It's a mix always of everything, so it's the same with us. I think, centralized energy systems definitely play their part, but it's the bigger players that should kind of, I suppose, run them and be responsible for them. But what we're seeing, and it's been really exciting for me because I love, I used to be in community engagement and I just love interacting with people. It's all the homes and businesses that are like coming out fighting for themselves, essentially. It's kind of sad, they shouldn't have to, but that is what's happening. Because they realise the power of having your own on-site energy supply. It's priceless almost, So, yeah.
This is a funny idea, and I've actually heard it come from quite a few small companies I've spoken with. Is that there's a segment of small to medium-sized businesses where the cost is actually less important than the concept of energy independence.
Absolutely, yeah. And I would completely agree with that.
Having an on-site guarantee,
yeah.
Which sounds kind of weird.
No, that's 100% been our experience as well. So like I've done about 300 customer interviews now at this stage, and we have a script. And another thing that was very surprising to me was I had a question at the end, have they mentioned the fact that it's clean energy? And they never do. I think there was like one or two where they actually was like, the fact that it's clean is, really important to us. So it's cost, but more importantly, the number one thing driving our customers is security.
We were speaking with someone this morning and they were explaining that until you reach cost parity with a legacy system, you can't even bring up the concept of renewables or about sustainability, because until sustainability catches up on price for the big scale stuff, the big guys are not going to move, right?
Yeah.
Whereas at the small business scale, it seems
it doesn't matter
it's
as
flipped
much
on its head in a way.
Yeah.
That sustainability is almost becoming the second argument after independence and costs, or the third argument after independence and costs.
Yeah, like a lot of our customers, when we would actually ask them, what are you currently paying for your energy? And they don't know.
Yeah.
They actually don't know. And I'll dig out my energy bills there and I'll send them on to you. So they don't even actually know. But it's the security, 100%. It's, it's that sustainable, it's right there. And I think the great thing with our unit as well is it's so tangible. You can see it, you can literally see it making energy. You can see the turbines moving and you're like, that's my power that I'm using.
I think there's a little bit of nerdy satisfaction in that from
Definitely.
a specific group of people, probably, certainly farmers or agriculture people.
Yeah. They're actually they're quite therapeutic to watch, I have to say. Maybe that's just me, I'm biased, but
it's your side benefits of
yeah, but they're just very slow and they're very gentle how they move, and they are actually kind of nice to just watch.
Cool. We've spoken tons about the technology. I actually had one other question, which is just some of the challenges in terms of physics here. Like, rivers are not easy places necessarily to work in. What are some of the big challenges you still have in terms of, like, a river, the water is moving at different speeds in the middle of the river towards the side of the river. You've got debris, you've got storms. There are certainly still, it's not as though this river, because it's slow moving, is suddenly a perfect environment for you.
Yeah.
What are the big obstacles which do exist and how are you dealing with them?
Yeah, I think, to be fair, our unit manages debris very well in a natural way, but big debris, no. So the way we're rolling out our product now with our first pilots is putting like rows of them across the river, because that again is maximizing how much energy you get out of the river.
Rows vertically down or horizontally
across? Yeah, okay. So almost as if you were putting a bridge across the river and like the pillars of the bridge, but there's like 1.8 meter gaps between them. So like, someone in a canoe or, people can pass between them pretty easily on small craft. But anything bigger than that is an issue. So yes, if you have a huge tree coming down the river, that's not going to be good. Yeah. So that's our kind of main remaining challenge, I suppose. So small debris is fine. Like, how we're getting around it is a lot of the sites that we're looking at now, upstream of them, they'd have a couple of existing weirs which just catch that big stuff anyway. So once it gets down to that site, it's not going to get down to that site. Right. But that's obviously, again, that's not scalable. So the first project we're doing now in Cavan, which is a really busy pub restaurant right alongside a river, we've developed a whole new deployment concept where we actually deploy them via an overhead cable. So you literally put two piles either side of the riverbank, you put a cable across, and you suspend the units essentially from the cable. So the other huge advantage with this is you're not putting anything into the riverbed. So literally nothing is touching the riverbed, which again is another huge benefit. What we do then is install a very simple vision system upstream, which detects if something really big is coming, and all the units lift up out of the water.
Okay, this is old school. Like when something big comes, just pull the whole thing out of the water.
Yeah.
Because it's small enough and light
just
enough
lift them.
that you can do that.
Yeah. So it's very doable. Like everything is there from the tech and the engineering point of view, but we've never deployed them that way before, but that's how we're going to be deploying them now.
I know from some of the other marine-based companies we've spoken to today as well that, water is just a big scary thing when the weather turns, and the weather turns quickly.
Mm-hmm.
If the water speed really rises a lot from a storm surge or something like that in the river, does your unit just handle it, or is this still a danger?
Yeah, it's got a certain cutoff point, obviously. So, because they're floating units, they just will rise and fall with the level. But definitely once it gets to kind of 3 to 3.5 meters per second, we would just haul them out, basically. Yeah. Okay. They'll automatically stop anyway, they'll actually stop turning. But as well, when there's storms and major kind of flood things like that, there's a lot more chance as well of debris coming. So there's a lot of really cool AI data systems now that are getting really, really intelligent with flood prediction, where it will literally tell you, it's going to reach this level by this time, so you need to actually take them out. So again, it's a huge part because they're so easy to move. You would just take them out.
Let's move on to talking about the money and talking about the business. You've already kind of explained that you're currently focusing on this sort of small business, small farmers group, which is obviously very keen with the whole energy independence thing.
Yeah.
Is this the plan going forward for you guys, or do you also mentioned that you're looking at a lot bigger units as well?
Yeah.
How are you seeing the path laid out before you in terms of business growth?
Yeah, we have a very clear path for once, which is great, because we did, to be totally honest, struggle, I suppose, with the commercial vision for a while, because we were so focused on the tech and the R&D that, and that's natural. You're kind of focused in that phase, but then you have to swap over and kind of be like, okay, what's the model here? How are we going to scale this? So the smaller river units, the first pilots we have going are with, kind of hand-selected customers that are really champions. They're very much part of the journey, and as I suppose a benefit to them, they're actually getting to buy the equipment outright. That is not the plan longer term.
Okay.
So the plan longer term is that we will actually do it based on resource, which we already have this underway. So we go out and we find the best rivers that are going to generate the most power. We then identify all the businesses and homes and farms along that. So we've done this already with one river in Ireland. We have a second one underway. So the one in Ireland, it's the River Shore in Tipperary. We identified 35 businesses and farms along that. We approached them and said, would you be interested in signing up to a power purchase agreement? Basically, you'll commit to buy energy off us for the next 10 years. We'll give you a 10% reduction on what you're currently paying, and we'll lock that price in for 10 years. And they literally were like, absolutely.
I'd love to hear more about this experience. So did you actually go door knocking in a rural area and be like, hey, look at our power generating small boat looking kind of thing that sits on the river. We'll sell you electricity behind the meter for cheaper than the grid?
Yep.
You did that?
Yeah, absolutely, yeah.
What people say?
They literally were like, where do I sign? How do I get this? And some of them now just ring us constantly being like, how's it going? When am I going to get it? So, but that, I suppose the other advantage of that model is it's streamlining everything as well. So where we're doing that on the River Shore, it's like a 30-kilometre stretch of river between kind of two big enough towns, and then there's not much in between, but there's lots of power hungry businesses and farms. So we basically are going to streamline the planning. So instead of going for planning permission for one site, we're now going for planning permission for that entire stretch of water. And again with the capex, so instead of building one station of units, now we're putting in to build 10 and then another 20 added on after that. So everything then becomes streamlined. So the capex, everything. But we actually pay to put all that kit in, and then we sell the energy. Yeah. And that is a way, way more attractive revenue
you're
model.
having to build microgrid infrastructure then, I assume, as well, if you're delivering to multiple
We do
locations.
that with a partner. We're not going to actually do the grid side of it. So, we'll have a partner who'll do that. So basically what we're doing with our initial commercial pilots in Ireland is we're figuring out all of those kind of side elements of who's going to be the perfect partner to do that. But definitely our goal is that larger scale, I suppose, where you have modular stations dotted down along a river, and you're selling that energy directly into the businesses and the homes that are right alongside that river, because it's their resource. And it's a very easy sell. Who doesn't want guaranteed energy at a reduced price for the next 10 years?
Yeah.
So,
how is the discussion There's, of course, a discussion about variable power pricing happening everywhere now,
Mm-hmm.
and suddenly the whole industry is shifting from, oh, maybe individuals can become power producers.
Mm-hmm.
No one really knows how this plays out, I guess, in the next, whatever, 10, 20 years.
Mm-hmm.
Is it benefiting what you guys are doing, or is it still just really too complex to be able to say to individuals or small businesses, hey, we'll make you power and sell it to you. You might be able to have some arbitrage here to sell it back to the grid as well.
Yeah.
What's happening in that space from your viewpoint?
Yeah, it's very interesting, and I think what's good is things are moving in the right direction now, definitely. So there's a policy in Ireland called the private wires, and I think that's already actually up and running in a couple of European countries, where basically people can free trade their energy with their neighbour, which again I'm so passionate that like it's your resource. You should be able to do that, you know. So at the moment for us, we're kind of hand picking projects where the customer is using all of the energy. So because people talk to us about, you know, the grid and selling back to the grid, and it's just another complexity that we don't need while we're just getting going. But absolutely down the line, if someone has excess energy, which they will, you know, they can sell it back to the grid. But my preference would be, instead of them selling it to the grid, they're selling it to their neighbour or someone much more nearby, because they'll get a better price for it as well.
Yeah. Use it where you make it, right?
Yeah, like the most valuable kilowatt is when you produce on site and send nowhere, that you use it yourself, because you're not getting any transmission losses, there's no middlemen, you know. So as much as we can, that's what we're trying to do now with our initial project.
Okay, and then what about your business itself? How are your guys' plans looking? Like, are there any financial blockers? What are the most difficult things you're going to have to overcome in the coming years?
Yeah, I think like we're laser focused now on getting these first pilots up and running, and then the hope would be we're putting a huge amount of work into these pilots, and just all the background work as well in terms of collecting data, you know, how we insure the machines, how we, you know, the warranties, all of that kind of stuff that you need to have in place for really scaling up.
This feels like a minefield. Rivers are one of these resources which people just look at as a very natural place, right?
Yeah, which they are.
Yeah. For some reason, shoving a wind turbine 10 kilometers offshore feels, I don't know, somehow less impactful than putting something in a river right next to your house.
Yeah.
How are you finding the regulation journey? Because I'm assuming that this is very much tied to capital as well. When the regulators are moving, you guys are, the money unlocks and the whole ecosystem starts to make sense.
Yes, absolutely, yeah.
Has it been really tricky, or have people, you said you've gotten into some very sensitive locations?
Yeah, so like we got the planning granted in the Natura 2000 site, which, you know, that was a really, really tough site to get into. It was in the middle of a city. There was lots of boat clubs, lots of protected species, and we got the planning grant there. But that was an EU funded project, and it would not have happened if it wasn't funded, because, you know, there was a lot of hurdles. We had to do, you know, really extensive studies and reports that were expensive. But because we've that done now, we kind of have that as a precedent in a case study. So, and part of that learning, to be totally honest, that was a tidal site. And we got the planning granted, but we never actually got the foreshore license granted, which is the marine side of it. So again, as a business, we had to look at that like very seriously and say, okay, if we go into rivers, we don't need a foreshore license, we just need the planning. And most rivers would be slightly easier sites to get into. So hence why, again, we've picked the river sites, and just the resource as well. The river, like if you have a good river, it's going to run 24/7. It's going to run, you know, through the night. And the massive thing with our customers is that it outputs most of its energy in the wintertime.
Yeah.
So that is huge. So like a lot of our units and the sites we're looking at, they won't actually generate anything in the summertime. So like right now you can see like all the rivers, their levels drop way down, rainfall is less, but around September time is when our units will start to kick in, and they literally just peak and drop off again around April, May. So if you have solar on site and you've got a couple of these, you've got like a really resilient solution, you know, that's going to work and balance itself out across the course of the year.
Yeah, fantastic. Yeah. It's sort of solar and wind can be complementary, but the winter dip is always the thing with which all of these smaller systems struggle with.
Yeah,
right?
And again, it's a mix. You know, it has to be a mix, because like one of our customers recently, he was like, you know, we did an analysis of his site and he'd really good potential, and he was like, sure, I won't need the solar at all. So, and we were like, no, get the solar, you know, because solar is a fantastic, you know, it's really cheap, I suppose. Now it pays back for itself, you know, there's no risk. So we would really be encouraging people to use the mix that they can, you know, so that they have, I suppose, as strong a solution as possible.
Cool. Okay, let's wrap this up. closing questions are a little bit more zoomed out to how you feel about technology itself and its potential. You guys have already solved some cool problems and built something fun, so I'm guessing you're a little bit optimistic.
Yes.
How do you think about these things just at the sort of world scale of technology's ability to change the way we do things in a positive way? Are you excited for the future or not so much?
I am, thanks to our customers. So, like, to be honest, we had a mentor a year or two ago, and he gave me a really great one-liner, and he said, wherever you're getting the yeses, give that oxygen. And he said, just go back, look back over your calendar, look back over your emails. Where are people like, really rallying for this? Where are people saying, I think this is amazing, I want to help you do this? And it was all the customers. So, our whole model now has really shifted to, just that decentralized community kind of spirit, because the technology is there. Like, everyone says that all the time. The solutions are there. And it's like, why aren't they being rolled out? Why aren't they being adopted? And I'm very passionate that they have to be democratized. So people should have the right to generate power alongside them if they have a resource there to do that and use that. So I suppose for me, it's really trying to empower communities and businesses to, just to harness that resource and have that long-term security,
I think we should end there. That's the end of the high note. Yeah, perfect.
Okay.
Thank you so much.
Great. Thank you.